long. So the last thing I want to show super quickly, a lot of folks may have seen this already, but I just want to show the smart contract management feature on Kaleido and how easy it is to interact with smart contracts, not using Web3 JavaScript, not using Nethereum or a thick SDK or a thick client library, just doing basic web development and RESTful programming. So I'll go into the new Kaleido console here for the latter half of this demo that we have here. And I'm going to go to my consortium level view or my network view. And we're going to use our shared asset class here. And we're going to create a contract project. So this is just going to be a namespace where we can have some source code. We can iterate on the compilations of that source code. And then we can ultimately start promoting it into our environments, into one or more environment. And we can create, a very hardened application. So I'll call mine simple storage. It's the one we always use. And I'm going to import it directly from GitHub. I don't have to, paste source code. I don't have to do a compilation myself. I don't have to do any of that heavy lifting, any of those Web3 responsibilities. I can just tell Kaleido about the endpoint to my .sol file, give it that URL, and Kaleido will do all of the other heavy lifting for us. So here's the namespace for the contract project. And now we want to create a compilation within it. So any of these buttons at the bottom or in the top right. So I'll call mine version 1 of simple storage, and now it wants the endpoint. So here's simple storage. For those that haven't seen this one before, it's a single global variable. It's a positive integer, and then it has two methods. It has a set and it has a get, and it takes an argument to the constructor when we instantiate it. So very, very basic, easy to wrap your head around. So I'll copy that URL, paste that right there, and then we can just let Kaleido auto detect all the other information. And this will ultimately spit us out that binary interface that we need to use to encode and decode when we're speaking to the EVM. And it'll also give us the raw compiled bytecode that gets instantiated on the blockchain. But ultimately what it's going to do is it's going to serve us with a set of open APIs that have those methods that we just looked at. We're going to see clean REST APIs for our sets and for our gets, and we'll have a root post method that we can use to instantiate this guy, to actually deploy it onto the blockchain and bring it to life. So there's the AVI, there's the bytecode, there's the dev docs if those are written inline, and now we can promote this to an environment. And again, the idea here is to, harden on your source code, iterate on your Solidity, promote it into dev, promote it into UAT, and then, once everything is behaving as expected, you can take that exact same code. You don't have to change anything in your application, and you can promote that into your production or your pre-prod environment. So we are going against demo, I believe. So let me click this guy. And we can just give it an endpoint for those APIs. Call it whatever you want. I'll just call it SS. Choose the environment that we want to promote it to. We're going into demo. And now we're going to have a bunch of open APIs that describe that smart contract, that describes simple storage. So we have no instances. We haven't deployed this on the blockchain yet, but we can go ahead and view those APIs, and then we can choose to instantiate this. So I'll be viewing it through node number 1. That's who I'm going to send the transaction through. In the past, we've talked about a lot of the different signing techniques. So you have this KLD from parameter here when you're using the Kaleido REST API gateway, and Kaleido will let you sign with any key that it knows about. So if you have accounts on your node, or you have accounts in an HD wallet or a Kaleido managed wallet, or even in a cloud HSM, you can enumerate any of those Ethereum addresses, and Kaleido will do all of the redirects and intercepts and sign that object for you. Just as an aside, a particularly useful feature here, if you're going to do signing and account management on behalf of a bunch of end users, where you don't want to have a Web3 application, you don't want to have them externally managing their own keys, this is where you could use an HD wallet instance in Kaleido. So you can very easily map your existing IAM service, your existing LDAP or Active Directory to an index inside of that HD wallet, right? So John Doe equals index 1, Nick Gaske equals index 2. And then it becomes very, very easy for them to authenticate into your identity access management system, and then have that corresponding mapping to the account that you want to sign with them for. So this is just going to be the account on the node here, nothing exciting. We're going to submit it synchronously through our Kafka tier, meaning we're going to wait for that transaction to be mined and executed before we get a receipt. And then we can actually give it a human-friendly name. So we can call this whatever we want and not have to deal with a hexadecimal address when we're talking to the smart contract. So I always just use simple storage 123 as a shorthand. And then again, we need to pass it positive integer to the constructor when we instantiate it. And I'll just keep going with 123 here. So this will take those open APIs. This will take that gateway API that we got as a result of the compilation, and this will give us an instance of the smart contract on the blockchain. This is us not having to use Web3 or do any of the, the esoteric things involved with programming against Ethereum, RLP encoding, nonce management, etc., and just use these basic RESTful calls to instantiate and interact with our smart contract. So I can close this interactive Swagger screen here, close this, and now within our Gateway API, we see that we've created a specific instance of that Gateway API. We've created a smart contract. And we can create as many instances as we want. And again, this is a particularly useful technique where you have a piece of source code, you have a smart contract, but you don't want to store all of your state on that existing smart contract, right? You may want to separate between different departments or just different divisions or different geographies, but you want the same underlying source code. So you could create an instance for simple storage 123, New York department, simple storage 123, London office, etc. Just to give you an arbitrary example there. And now we can interact with this instance. Again, I'm doing this through the console here, but for a developer, for a programmer, this is a really trivial thing, to do with a basic node program. You just put a little Swagger client in it, you get your application credentials, and you point at the corresponding endpoint, for this instance, for this smart contract. So if you were programming against this, for example, you would want to have some application credentials injected inline or base64 encoded and passed as a header. But this is the API, this is the URL that you're targeting, and you're submitting those transactions through a node that you own, through node number 1. And then you just have these basic methods here. You could subscribe to the set method, right? This is an event that's been created and you can get further information. We talked about event streams last week, and we're going to retouch that in an upcoming week once we migrate that feature into version 2. But the idea here is that we don't have to do any complicated Ethereum stuff. We can literally just call post, call our set method, and we can update that state. And we can stream this asynchronously via Kafka. So basically, we're just going to get an acknowledgement from that Kafka topic that it's received this payload, and then we're trusting Kafka, we're trusting the ETH Connect tier of Kaleido to buffer and queue that transaction and submit it to the network at an optimal rate. So we'll give it another argument. We'll take a quick peek at the block explorer. What's the date? Is it the 16th? I'll give it 16 for the day. I think that's right. And this will fire back immediately. So this is just the Kafka topic saying, hey, yeah, we got it. Here's the acknowledgement, and we're going to execute that transaction as it makes sense for your environment and for your algorithm. I talked a lot about the functionality of the REST API gateway. I'm just going to show the picture super quickly, so for some heightened context here. But the idea is this is where we were acting from over here. This would be the application. In our scenario, this was the interactive Swagger interface that I was using. And we were just giving it lightweight JSON objects, right? I was just giving it an unsigned integer inside of some curly braces inside of a JSON object. We uploaded our source code into the API gateway. We had a smart contract project that ultimately turned into a compilation, and then it turned into REST APIs. And then Kaleido surfaced those REST APIs for us to first instantiate those APIs in that source code and then start interacting with an instance of it. And we have this shim, this middleware underpinned by Kafka, that's doing all of the things we don't want to do when we're talking to Ethereum. We don't want to have to compile our source code. We don't want to do RLP encoding. And we really, really don't want to do the sequencing or the nonce management. This is such a huge gotcha that results in queued transactions for all types of projects. And then lastly, we just tell Kaleido how we want to sign this object. Remember that KLD from parameter, potentially the most important parameter in this whole scenario here. All we have to do is tell Kaleido how we want to sign that object. Again, that key could be in the HSM, it could be on the node, it could be in the HD wallet, or it could be in another managed wallet service. So I'll hop out of this screen right here. We'll go back into the console, and then we'll just take a super quick look at the Data Explorer here. Within the environment, I guess I'm going to show one more thing too. We have this new address book functionality that really gives you a rich, holistic view of all of the runtimes and all of the memberships that are in your business network and in your environment. And it even lets you drill down deeply into specific memberships. So you can see all of the associated signing accounts. You can see all of the nodes, all of the ancillary services like document store, app-to-app messaging. And you have this, this clear line of sight. So it's fantastic for operators, for administrators that really, really need this, collective view of everything that's going on inside of the network. So for example, if we click our destinations tab, I see that I own 2 destinations, right? These are the memberships, but they're both owned by organization ABC. We can see all the available signing accounts that are on the nodes here. And then we can even dive deeply into our on-chain registry service as well. And you have a fully time-stamped audit log of everything that's taken place inside of the network. So it's a really, really useful feature here that's been exposed on Kaleido. So just to give you guys that knowledge. And then the last thing I wanted to show was just the new revamped Data Explorer and Block Explorer. So we can go ahead and have a dashboard view. This won't be terribly interesting because we haven't done much, but we did a deployment and we did an invocation of that smart contract. And then we can start interacting with these transactions. So this was the one I streamed asynchronously via Kafka, right? It just returned immediately. But we see here that it was executed, that it was mined, and we can see the method or the function that I called, and we can see the arguments that was passed in, as well as the endpoint or the smart contract that we were calling, the transaction hash, and who signed that transaction as well. So you have this really, really rich collection of data that you can drill as deeply as you want to into any of this. So going to pause there, give everyone a couple minutes to throw any questions into the chat. I'm going to also share my email in the chat if you guys do have any technical or business follow-ups that you'd like to engage in. So let me share this with all attendees here. And again, we can dig into your use case. We can talk commercials. We can talk any technical concerns. Really happy to go through any of those packages that I touched on. Happy to allow the clients to drive the conversation. And I would also ask a favor from everyone. If there are topics that you are interested in that you'd like to see covered on future Tech Tuesdays, if you do want to see event streams again or Cloud HSM signings, more private document exchange, more full stack decentralized apps, go ahead and throw those in the chat or reach out to us, and we're happy to structure these and cater these so that everyone gets the most value out of them. Going forward, we will showcase all of the new features as soon as we upload them into version 2 of Kaleido. So you will get document store and you will get event streams again in the next few weeks. But there's such a rich suite of functionality in Kaleido. We have the Ether pool, we have the tokens, we have upwards of 20 embeddable, pluggable services. So I'm happy to dig as deeply as you guys want into any of those as well. Yeah, so a couple of questions. Do you have control over SolC version? Yeah, absolutely, Ian. You can just, the feature I showed was Kaleido just auto-detected the Pragma inside of that Solidity code. The other questions is Kaleido a hosted central server? So Kaleido is a distributed, fully managed cloud platform. So we're using servers, across AWS, across Azure, with all of that layer 2 virtual networking, all of that firewalling, and all of the management and auto scaling and DR of those runtime components, right, of the nodes and of those ancillary services, preemptively deploying additional VMs so that your environments can very easily dynamically scale. All of that is hosted behind the scenes here. It can very easily be spread across multiple clouds. You can leverage multiple regions in a single cloud provider, or you can even leverage Azure and AWS within the same business network. We're also continuing work on trying to make a privately hosted Kaleido node a lot more of a streamlined experience, excuse me. So taking that private stack, taking that software, running that on GCP or running that on premise or in a cloud of your choice, but still having the same experience, being able to securely tunnel back into the Kaleido hosted runtimes and still leverage all of those easy, clean APIs and all the functionality that we've shown on Kaleido as well. Okay, so that was the Q&A. I think there's a couple in the chat as well. So the two questions in the chat, this will interface with Hyperledger as well. Yes, we've proven that it can very easily interface with Corda. So I don't think that's a far-fetched idea to say that Hyperledger could be a future protocol, and any of the Hyperledger protocols for that matter on Kaleido. George's question was around the baseline protocol functionality. That question is starting to be asked a lot more frequently. So we're starting to have some internal conversations, but I'm not going to say yes or no to that. But there is a lot of value in that baseline protocol and sort of the service bus and I guess indelibility between enterprises and cross-organizational communications. So stay tuned for updates on baseline for sure.